We are the COPE team, and we are going to present you our project of data mining. So for this project, we are going to deal with natural language processing with disaster tweets to predict if disaster tweet is real or not. Our dataset consists of tweets about disaster, and it contains 5 features: ID, the ID of the tweet, text, the disaster message, and the keyword disaster category, location where the disaster happened, and the target it reported if the tweet is is a disaster or not. So here is an example of a disaster tweet. As we can see, the tweet contains a word catastrophic, but the fact of that doesn't make it a disaster tweet, a real disaster tweet. So how we did play the game? We started firstly by exploration data, and based on the results and the conclusion that we got, we did some cleaning and pre-processing data. Then we applied our models on these pre-processing data, and based on the results we got from these training models, we make some changes on the cleaning and pre-processing phase, and so on.
Well, our very first intuition was to compare the distribution of the fake class against the real one. And we could notice that the fake one was more. Actually, there were more fake news, more fake tweets than the real one. And apart from that, the was to compare both the classes, the class of the real one and the class of fake tweets. And we could notice that the fake one was more. So as in there were more fake tweets about disaster than actually there were the real ones. And there were like 50% of base rate, which means that the data set is actually balanced. Moving on. Yeah, then we thought of seeing how the world is actually, behave, how it behaves, how its characteristics are like. So we have compared of both the classes against each other. We could realize that the fake news word lengths were longer than the real ones, even the characters. So make some analysis around where most of the fake tweets were originated. So we found that, for example, many of them came from New York, and also places, location where, like US, were actually replicated many times, but then in different forms. And location was not clean, so we had to clean it somehow.
Yes, data cleaning, both real tweets and fake tweets, they contain web pages, hashtags, retweets, user references. So this is not clear to determine whether a tweet is real or not from these references. So we still need to clean the data. We need to remove the characters. We need to remove the stop words to increase the efficiency and the accuracy. So here, basically, we make use of the two kind of cleaning. The first one was the spicy tokenizer, which doesn't contain stemming, and the second one was with the stemming. So the difference between them will be seen here. So the second one is with the stemming. The first one is without the stemming. As you see, the words are changed a lot with the stemming. So when we run the the fitting. With the stemming, the accuracy was decreased, was reduced. So we concluded that we shouldn't clean more. So vectorization. So since the tweets are shorter text, so it is better to use the vectorization, the TF-IDF vectorization. We also used the vectorization in our models. So we tried different models with the same data, the logistic regression, the decision tree, the random forest, and the key neighborhood classifier, to compare the results. So as you see, the best result was coming from the logistic regression. It was 81.70%. And with the tree classifier, the depth seems to be very high. And also for the K neighbor classifier, we run a grid search to locate the hyperparameters for the higher accuracy. So this is also a graph from the tree classifier. As you see, for the word governor, the frequency is high, and also its child leaves, so they are finished at a very early stage. So at the second level already, all the classes are determined. Also, we can conclude that usually the word governor seems to be in the class 0. So this is a chart to show our accuracies. So our accuracies basically were around 80%. So the highest one was with the logistic regression.
So actually, as can be seen that in order to improve our accuracy, we can deal with 3 things. The first one is the type of the model and its parameters. The second one is the cleaning and preprocessing techniques, and the third one is the feature selection. So which features we can consider? So the features that we considered are the text, the keyboard, and location features. How we did with that. So firstly, we start to test the models, the logistic regression model, only with the text feature, because we thought that it's the most important feature to predict if the tweet is a real talk about a real disaster or not. And then we test various combination of features. We merged keywords into text, and then we merged location into text, and then we merged all the 3. So we got some conclusions doing that. Firstly, we got that the best accuracy is it was with only the text feature, and actually when we applied our trained our algorithm without cleaning, only with the raw data, we noticed that adding location feature to the text feature decreases considerably the accuracy, but after cleaning, adding it increases slightly the accuracy. Here it's just efficiency comparison between models. So as we can see here, that the logistic regression is the most expensive in terms of time, and KNN is the best one in terms of time. But as we see before, the logistic regression is the best in terms of accuracy. Here we applied, we trained logistic regression with two different vectorizer. The first, it was a simple one, and the second, it was with the spaCy tokenizer with cleaning. So as we can see, the accuracies of both are very close, but the time is considerably different. So the question that we may ask here, if further cleaning and preprocessing, is it worth here or not?
Now, all these analyses and our early assumptions, with the findings, we sum up everything together, and they've helped us to come up with a better approach. As in, we thought of changing the way we are cleaning. Those are tweets. So tweets are not like all the remaining text. So we came across one particular library, Ekphrasis, which actually help us to process the tweet. It's meant for that. It can correct the spelling errors. It can be customized. It can deal with emojis very well. And we also thought of keeping the duplicate data, because the data set is very small, so we don't need to drop some part of them. And of course, location, many were missing. So early, we dropped them, but this time we thought of keeping them as well, and keeping them while putting some tags. And to finish, instead of merging everything together, we just thought of, maybe we can generate CFID of each one, and then at the end concatenate them. And with that matrix, we can apply PCA to reduce the dimensionality. So that's pretty much about what we did.
Thank you for listening us.